This is the video for Math 117 1.1c. Some of these concepts were covered in class time this week, so look at the resources page for the Chapter 1 assignments, and there is a feed there for the Zoom class time that was recorded. So the first problem has some crazy exponents in it, but you should just be able to distribute and multiply, adding the exponents where you're supposed to. Now, negative 1/4, x to the 1/4 times x to the negative 1/4 is going to give me x to the 0, which is 1. So that's important to realize that that's what you're looking at there. We did factoring out the greatest common factor here, so you should be able to do this one pretty easily. Send me messages or check in at my office hours on Monday or Tuesday to get more help with these problems if you need it. Factor out the greatest common factor here. Well, I'm really just taking x to the highest power that they both share, so this would be x to the 1/3, and I'd have to take out x to the 1/3 here, which leaves me with x to the 7/3. So those are the kinds of things you need to be thinking about. Factor out the greatest common factor here, same thing. This one has some strange thing in it, but you're just going to write that e to the xy to the 5th, and you're going to have a y that's coming out 2 and a 5 that's coming out. Then you write down what's left over. Note that the entire first expression here is going to be factored out for both of them, so you'll be left with a 1 for the first one. We did one of these in class, so look back over the video. It's done exactly like any other factor by grouping. This one's a difference of squares, but first you're going to have to factor out a 6 to be able to do that problem. This one is factoring a trinomial by unfoiling, and we did several of those examples. Number 10 here is a difference of squares, so you can factor this just as if it were x squared minus 16. It's x plus y squared minus 16, so you'd have x plus y minus 4, x plus y plus 4. It's just a matter of understanding how you're going to write that down. These two are, well, this one is unfoiling, but it doesn't have a 1 for the leading coefficient, and there's nothing that can be factored out. So I need to show you this one. This one you can factor something out, and I'll show you a similar example for this one. First, we're going to do a little bit of a review. So the first problem here is a factor by grouping. And the procedure is, when I give you 4 terms, more than 3 terms is what you're looking for, you're going to group the first 2 to do a GCF, the second 2 do a GCF. So what they share here, the GCF is what they share. I'm going to pull out 3c, and I'll be left with 2a plus b. Now over here, if that actually does factor by grouping, if these are in the right order, and I will put them in the correct order for you on the test. You might have to rearrange in real life, but on the test you'll see them in a correct order for just grouping right away. So here I should be left with a 2a plus b. So if I take a 2a out of this, I'm left with a negative 2d. So if I multiply this, negative 2a, it gives negative 2 times 2a is going to give me negative 4ad. Negative 2d times b is going to give me a negative 2bd. So that works. Now these share the 2a plus b. Those should be the same. If they're not, you made a mistake somewhere. So I'm going to pull that out first and write down what's left. So over here I'm left with 3c, and over here I'm left with a minus 2d. This is incredibly easy. Don't overthink it. Practice it until it makes sense. Now we did several of these in class, so again, look back at that Zoom meeting if you need to. I need the factors of 18. The factors of 18 are 1 and 18, 2 and 9, 3 and 6. That subtract to be 7. That would be 17. 9 minus 2 gives me 7. So this is what I'm looking for. So I'll have x in both of them, and then the 9 and the 2. And it doesn't matter which way you put these. Negative means the signs are going to be different, so it's going to matter which sign I put where here. The largest sign will be positive, and the 9 is larger, so it's positive, and this one's negative, and I'm done. This is a difference of squares, and we had a formula for difference of squares. So it's the square root of the first, which will give me 3x, minus the square root of the second, gives me 4y. And this will be 3x plus 4y. If I full this out, the middle terms are going to go away, and I'll just be left with 9x squared minus 16y squared. This one there's a formula for. So the formula says a cubed minus b cubed is going to be a minus b times a squared plus ab plus b squared. So you need to know those formulas or you won't be able to get this one correct. So make sure you're memorizing the formulas. I need the cube root of 27, gives me 3, so that's what my a is. The cube root of 125x cubed, well, 125 is 5. I keep the sign, and this will be x. Now, in order to get that 27, I actually need a 9 here, which is 3 squared. In order to get 125x cubed here, I'm going to need a 25x squared, which is this quantity, squared. And then I'm going to have a positive, and I'm multiplying these two. So once I have my a and b, I'm only using those to fill in for the second part of the formula. So this will be plus 3 times 5 is 15x, plus 25x squared. This is a sum of two squares, and that's prime. So I wanted to remind you of the factor formulas. Here they are. You could pause and take a picture if you want to, or pause and write them down. But these formulas are the 6 that you have to know for the test. I'll ask you these 6 formulas, so be prepared to write them. You also need to understand the factoring procedure and the quadratic formula. So you could pause and take a picture, or pause and write this down. You will need to know how to do the factoring. I won't ask you for this, but I will ask you for the quadratic formula. Now, before we go on to the next problem, I'd like to go back and revisit here, because some of you will have a difficult time getting this list of factors. So I'm going to show you a way on the calculator to do that. There's a short procedure to get the list of factors for any particular number on this calculator. And it's not difficult at all, but you have to study the procedure. So I could clear the main screen if I don't want anything on there, but I'm just interested in y equals. If you have something in y1, get rid of it, and if there are any of the plots are on, make sure those are off. So your screen should look like this when we get started. I'm going to go to second table set. I want the table start to be 0, the delta table to be 1, and both of these keys to be auto. So in y equals, I'm going to put the number that I'm interested in, 18, divided by x. This will give me the factors if I look at second table. So I can see dividing by 0 is going to give me error because it should. But this tells me 1 times 18 works, 9 times 2, 3 times 6. This is a real quick way to get a list of factors. Let's practice again. So let's do second quit. Go back into y equals, and let's try the number 56. 56 divided by x. So second table. And I can see 1 times 56, 2 times 28, 4 times 14, 7 times 8, and then it repeats. 8 times 7 is the same as 7 times 8. So you get a short list of the factors that you need if you have a number that's larger. I will give you things that are larger than 18, and I have done as much as doing like 256. Let's see, 259 divided by x. So if you do 259 divided by x, do second table, I can see 1 and 259, 7 and 37. So you should be able to do any number I give you now. You have a way to do that. So study that procedure if you need to. So what do we do if our leading coefficient is not just a 1? The unfoiling method of the factors of the last subtract a b works beautifully if that's a 1. So what we're going to do is apply a little trick to this. I think it's called slide and divide online if you look it up, or divide and slide. So what we'll do is we'll change this into a problem that we know how to do. So I'm going to draw a line right here, little box, and I'm going to multiply the first to the last. Now this is the weird thing I'm doing, and I'm going to have to undo it when I do this. When I finish this. X squared minus 4x minus 3 times 4 is 12. And it works if that's negative there also. So x squared minus 4x minus 12. Now I can factor this. This is the factors of 12 that subtract to be 4. And the factors of 12 are 1 and 12, 2 and 6, and that gives me 6 and 2 is right there. And then 3 and 4. Those would be my factors. So this is the one I'm looking for. Could have done it in my calculator. By all means, pick up your calculator if you need to. So this would be 2 and 6, or 6 and 2, either way. Factors are different. Largest is negative. This one's positive. Now I have to undo that 3 that I multiplied. So this is a very strange step. If you haven't seen this before, some of you have, I'm sure, because it's a pretty popular technique. But a lot of high school teachers do not teach this, so you might not have seen it before. It makes the guess and check completely gone. Takes care of it. And you might have another way of doing this. Some of you like to do the box method. I don't really want to do that method. This way is easier for me. But any way that you can get it factored, because I'll give you this question, something like this, and just want you to factor it completely. So here, I've factored this. I want to get rid of the 3. I multiplied, so my step here is to divide just the second term in each of these. So the first one I multiplied. The second one I divided. I factored and divided. Factor and divide. And then I'm going to reduce this. So I have x plus 2/3 times, and this one does reduce, x minus 2. So my actual answer here will be taking the part that's still in the denominator and putting on the inside. There is nothing in the denominator here. So I'll have 3x plus 2 times x minus 2. If you full this out, you'll see that it actually gives you the same answer. The second we're going to do the same way, and if you need more examples, just let me know, but pretty much it's easy enough to get this done if you understand the procedure, and you can go back through the same one several times. So here I'm going to multiply the front and the back, so I end up with x squared, and I usually put a little box in here because I've changed the problem here, and I want to indicate that, plus x minus 12 times 6. Now I know I'm going to need the factors here, so I'm going to go ahead and go into y equals and do 12 times 6 divided by x and get my table. So I can see 12 times 6 is going to give me 72. So this is saying this factors of 72 that subtract to be 1. 72 minus 1 is not right. Now look all the way down to 9 minus 8 is right. Now if you could have gotten these without going into the calculator, that's fine. All I need to do is see the work. So 8 and 9 are going to be my numbers. So I have x in both of them in the front, different signs, 8 and 9 here. Here the largest one is positive, so the 9 is larger, so it's positive, and the other one is negative. I'm going to divide by the thing I multiplied by, the strange step. So I'm going to divide by 6, and reduce. I get x minus, now if you need to, pick up your calculator. 8 divided by 6, math, enter, will give you the 4/3 that you need. This needs to be reduced. So we get 4/3. And then 9 divided by 6, math, enter, should give me 3/2. The last step is to write down the answer. The 3 comes out front of the x inside the parentheses. 3x minus 4. 2 becomes the coefficient of x inside the second one. If I fold this back out, I can real quickly see I'm going to get negative 12 there, and I'm going to get the 6x squared that I needed. And then you can do the outer and inner to see if that works. For the last one here, we're using the quadratic formula. And we had that on a previous lesson. So I'll just drag that out for a second. There it is. Some of you have a little nursery rhyme or whatever that you say to this because your teachers taught you this in high school. You should have seen it already. You might not have. So this, if I have this, I can use the quadratic formula to solve it. So this is x is equal to minus b, negative 5, plus or minus, so this would be my a, This is my B, and this is my C. Taking the signs with it. Plus or minus the square root of, let me put this up here so you can see it. The square root of B squared, well B is 5, so that'd be 25, minus 4, and I'm usually careful about doing this one. I'm going to put A in, that's 4, and C in, that's negative 6. All over 2A is 8. Anything I can do in my head carefully, or that I'm taking my calculator and doing, so I could pick up my calculator here. I'm not sure about 4 times 4 times negative 6. So that's minus 96, but it's negative. So this ends up being negative 5 plus or minus the square root of 25 plus 96. So I get two real roots. The minus 96 would have given me imaginaries, which is going to give me, if I put this in, 25 plus 96. That's 121. Now I know that's 11 squared, but if you didn't, second square root of, you can go up and grab that 121. You can see that that's 11. Make sure you're picking up your calculator if you need it. So this is minus 5 plus or minus 11 all over 8. Now this isn't completely worked out until you have those two answers, because I can do minus 5 plus 11 and minus 5 minus 11. I'm going to do the negative one first just because minus 5 minus 11 would be minus 16 divided by 8. So that gives me minus 16 divided by 8 is negative 2. Minus 5 plus 11 is 11 minus 5 is, what is that? 6 eighths. So this would be 6 eighths. And that's the same as writing negative 2. Always reduce. 6 divided by 8 is actually 3/4. So here are my two answers using the quadratic formula. So I just went over the procedure to do this problem using that trick where you have to multiply 3 times 12. Notice there's nothing you can factor out that they share. This one you're going to want to factor out what they share first, and then whatever procedure you end up needing to use. And this one is the difference of two squares we've already talked about. The next one here has A's and B's in it, and I'll show you an example of that one. We've already done one of these in class, and it uses the formula, so make sure you use the cube formula. And this one says perform the indicated operation and simplify. So it just means multiply this through and then combine like terms. So let's do the example like this one. You always want to make sure that you factor out anything that they share. And in this problem, 19 is a prime, so unless there's 19 everywhere else, nothing is shared. These two have an A and these two have a B, but not all of them have any of the same letters or numbers. Factors. So I'm going to do my little trick, and you can go off to the side and write this as 8a squared minus 19a plus 6 if it makes you a little happier to do that, but you need to put your b's back in when you get done. So if you're going to forget about the b's, then you'll miss that. But you could get rid of those b's. That's the thing that's upsetting you, is there's a second letter there. So let me work with this one, but you could do this if that makes you a little happier. Or a little less unhappy, maybe. So I end up with a squared, because this is the weird thing I'm doing, right? Minus 19ab plus 8 times 6 is 48b squared. So now I know for sure that in order to get the a squared, I need a's. To get the b's, I'm going to need b's. The signs are both the same and they're both negative. So I already know this information. All I need are the factors of 48 that subtract to be 19. And you may or may not know those. So let's go in. If I put in 8 times 6, which is 48, divided by x, second table, got 48. I want the factors that add to be 19. And I'm looking here, it looks like 16 and 3 add to be 19. 2 and 24 is too much. 4 and 12 is too little. 16 and 3. So 16 and 3. Now I'm going to divide out that 8 and reduce. 16 divided by 8 is 2b. A minus, this one doesn't reduce, 3/8 b. So my answer is a minus 2b. The 8 comes out front, in front of the a, still in that parenthesis, so it's a coefficient of a, 8a minus 3b. And that's my answer. In questions 14 through 16, 14 just says, perform the indicated operation and simplify. So you're going to be multiplying this across. You need to be careful with the negative when you're here. Just a little hint there. So you multiply this, multiply these, careful with the negative, you're going to have to distribute it, and then you'll combine like terms. This is an Algebra 1 concept, so it shouldn't be too bad. Perform the indicative operations. Notice here I have x squared minus 3x squared plus 3, so I can immediately write x to the 4th minus 9 for this. So there's a little hint. And then you'll have to FOIL it with this, being careful with your powers and your first, outer, inner, last sequence. Here we're finding the real roots of the equation by factoring. That's what we actually do when we find, when we use quadratic equation. We're finding the real roots of the equation by factoring. So I'm going to go back to my previous example and set it up so that you can see what you would do to put your numbers in here. So looking at a previous example that we did these like this, on numbers 9 and 10 as I was working today. If I'd had number 10 looking like this with an equals 0, I'd want to be solving for x. So that means I'd have to factor this, which it was factored in a previous example. So we end up with setting, by the zero product property, we set both of these equal to 0. So we end up with 3x minus 4 equals 0, or 2x plus 3 equals 0. So this gives me x is equal to, take 4 over, divide by 3. Add 4, divide by 3. In one step is fine. X is equal to minus 3 over 2. Subtract 3, divide by 2. So these would be my two x's if I was looking to solve this by factoring. Solving this one by factoring, you end up with 3x plus 2 equals 0, or x minus 2 equals 0. So 3 is equal to, x is equal to subtract 2, divide by 3, and x is equal to add 2, divide by 1, which is the same as that. So when you're solving by factoring, notice I put the braces in here, that's set notation. You just want to put your two numbers in separated by comma. So 3, 4, or whatever these answers end up being, which obviously they are not 3, 4. So we have more of those. Find the real roots by factoring. Here's find the real roots by factoring. My hint here is to multiply everything by 2 to get rid of this 1/2. So this one we've done a similar problem by factoring, and this one we've not done one by factoring, but you can multiply by 2, you end up with a squared plus 2a minus 8 equals 0, and it's easy enough to solve that. So you have several opportunities to practice using quadratic formula on this homework, but what I want to do is show you a way to check your answers. I'll need to see your work when you actually do these in class, so you can't just give me an answer. Answers are worth 1 point. So if the problem is worth 5, you'll lose 4 points if you don't show me work. So if I say using the quadratic formula, I'm expecting to see that you've used the quadratic formula. But I do want to show you what this would look like on your calculator, so you could check to see whether or not you have the correct answers on your calculator. So I want to see if this is equal to 0. So go into my calculator, formula, y equals 2x squared plus 13x minus 45. Now there are several ways to check to see when this is equal to 0. So one way would be using the table. So I have the table set. If I use the table, I want to check to see when my y value is 0. And I'm not seeing any zeros here, but I can see it changes sign in here, so I know it's somewhere between 2 and 3. And I have to be on the X to scroll up. So if I scroll up, I can see it change. Oh, it's actually 0 at -9. So one of my answers is -9. So I'm expecting to see the answer -9. Now for the other one, I would want to solve and see if I could find the zeros, but I'd have to do a graph to do that. So on y equals, I want to make sure that this has a dark equal sign, and I'm going to graph this by doing zoom 6. That's for zoom standard. And I know that this is probably the -9 that I just saw in that table. So this is the 0 that I'm looking for. So I do second, trace, that second calc, 2. And my left bound is, where do I want to look? I don't want to look all the way back here, so I'm going to put 0 in. You could scroll, but I want to look in between here, so between maybe 0 and 5. So x equals 0 is my left bound, so it's giving me a little arrow right there. And then my right bound I'm going to put at 5. Now it's showing me it's going to look in here for the 0, and it doesn't matter what you guess, but I can see it looks like about 2.5. And it gave me a 0. Oh, it actually was 2.5. So once I have this information, this was 2.5 and -9, then I can check to see that when I use the quadratic formula, I used it correctly. That's always nice to have a check on that. So going back to our others, we've pretty much gone through all of the exercises here. There's a formula that they're trying to see if you know how to use. So it's really just putting numbers in here to see if you can figure out what this formula is. And then there's a question about b squared minus 4ac. This is called the discriminant for the quadratic formula. Email me if you have any questions. Go back through the videos if you need to.